Hello, folks. I hope you're having a lot of fun doing programming these days and enjoying all the juicy details of each and every problem. So, today I thought about doing this classic interview problem known as Fizz Buzz. And then I was watching a video where somebody said that, hey, if you cannot even do Fizz Buzz, we do not even want to talk to you. So I said, well, that sounds interesting, and I've heard of Fizz Buzz before. So why not let's today do Fizz Buzz on Leetcode? And I went to see what is the problem number on Leetcode for Fizz Buzz, and lo and behold, it turns out to be 412. So today is the 412. I know that 420 is like a little bit ahead of it, but hopefully before we get to 420 we can do a 412. So what's the problem detail here? Let's take a look. It says write a program that outputs the string representation of numbers from 1 to n, but for multiples of 3 it should print fizz instead of the number, and for the multiples of 5 output buzz. For numbers which are multiples of both 3 and 5 output fizz buzz. And then he gives an example which is like n equal to 15, and this should be the example, is should be the output. As you can see, we have they have written, the output is an array where each element is a string representation of the number, with the condition that if it is a multiple of 3 we get fizz, multiple of 5 we get buzz, if we multiple of 3 and 5 we get fizz buzz. So let's try to do this problem and see how we can do. We are going to do this in C, by the way, because C is our current darling. So let's not be unfaithful to our darling. So let's try to see how we can do that. So first thing is, as you can see from the function signature, you're passing, basically you are going to return a array of char stars, so basically a array of strings have to be returned, and that's why you're having char star star. And this variable here is they're passing a pointer because we can update the length of this array of strings by updating this return size. As you know, in C, the way to change the values in the caller are by passing a pointer. So what we do is we have a variable like this, null. Then we have something known as n strings. Like, so this, what we would do is we will start by updating n strings every time we change the size of ras, and then we will basically return ras and write n strings into the return size. But that's kind of a detail which is to come later. Right now, let's try to do how we can solve this problem. So okay, now one other thing is it's from 1 to n. So here we can do like this, I plus plus, and now let's see what happens. Here what would happen, first thing we can do is we can take a temporary num on which we will do our work. We have another variable j which will come in handy hopefully very soon. And now we start the process of filling in the changing the size of ras and things like that. So first thing is to see that, because we have to make sure that fizz buzz and all these cases are taken care of first, we say that if it is divisible by 3 and if it is multiple of 5, we are in, we have to do that first because we should take care of this multiple of 15 or 3 or 5 case first. So num mod, oh sorry, num mod, see this is what happens when you don't code for a while. So if this happens, then what do we need to do? We need to have a string Fizz Buzz. So that is malloc strlen Fizz Buzz plus 1. Why plus 1? Because we have to have a null terminated. As you know, in C, strings are null terminated. And then we can simply do a strcpy fizz s and Fizz Buzz. Does it sound good? Now s is ready. We need to stick s into res, but res has nothing right now. We first need to do a malloc. But if we're doing malloc and like judging, we don't know what is the value of n. Actually, you know what? I have a feeling realloc is not really needed here. Because if you know that you're going to have n entries into the Fizz Buzz, the return array, why are we having to do this realloc? But let's take realloc, at least you will learn about realloc. So realloc, and we say size of char star. Okay, so realloc, by the way, takes your existing pointer also. So size of char star times n strings plus plus. But since in the beginning it is already 0, so we want to do a pre-addition rather than post-addition. This is a very typical C. So as you can see, now we have got a space in rest. Then all we need to do is say n strings minus 1 because indexing start s. So we just stick s in. Now you see the other two cases are kind of boilerplate, and they will be very easy to. Okay, one more thing. Once you have done it, we need to go to the next iteration. We don't want to continue to do what we were doing because we are already done with that I value. So if that equal to 0, if it is multiple of 3, we print fizz only. And here we say fizz only. And then this part is good, and then we are again doing continue. Similarly, for multiple of 5, we only print buzz. It's a lot of boilerplate code also in this. Once you figure it out, it kind of flows in and you can just simply keep adding stuff. So again, we do a continue. So we have taken care of these cases, but how about 1, 2, 3, I equal to 1, 2, 3 and all these cases. So that what we're going to do is, so we have num, so okay. So we would say that first of all, what should be the length of the allocation in the case of these numbers? And that's a very interesting problem because that's like imagine you can write a function on its count digits in which you can pass your num and plus 1. So that would be the, so s equal to malloc count digits num plus 1. So because we have to stick in a null terminator in this case separately, because in strcpy, by the way, copies the null pointer for you. The null character for you, so you do not have to do that separately here, but in this case you will have to do. So first think about how are we going to implement a count digits function, and once we have that, then it shouldn't be too too tough. So we'll say while num, we say int remainder equal to num mod 10, and then we say as j plus plus, because j is still 0. Remember, we always start with j equal to 0. As j plus plus equal to ram plus. This is a neat little trick of basically making it a string basically. So as j plus plus, and then is there anything else we need to do here? Yes, because we haven't finished all the digits in num. So num, this is an integer division, by the way. As you know, in integer division, all but the the least most significant is digit is discarded. If you want to write in a more C-like fashion, you could do probably something like this. Alright, so here we are. So now we can see that this thing, we are done out of the digits in num. Now is that all that we need to do? We also have to do now at this point null terminated, right? Null character we write. And then is that enough? Suppose we are given 1 5. What would happen is we'll get 5 first. So actually it would be a string at this point 51, something like this. But actually we were given 15, not 51. So how do we go from 51 back to what it is? So maybe we may have to write a function known as reverse s, and then this takes the length is given now, and then once that is done, then we have to again do the same thing that we were doing here. We stick into this array of arrays, array of character arrays, character pointers, pointers to cache. So basically array of strings, an array in which each element is a pointer to a string. So res, okay, and then we say sam again. Is taken as there, and we are good to go. When we are done, we just say, how about this thing here, return size? We have to basically update the return size to n strings, right? And then we just say return res. How about that? That's all there is required. But what would happen now is it will complain about not implementing these helper functions that we had to use, which are like, for example, we had a function here known as count digits, and then we had a function here known as reverse. Reverse is easy, as we all know. So we say void reverse char. I guess all of us know this trick about reversing a C string, right? Which is, we say that, okay, so int I equal to 0, we have two indices, one pointing to the front, other pointing to the end, right? And then we say for, nothing happens, our initialization is already done. We say while I less than j, I plus plus, j minus minus. So we have kind of, the front index is going to its towards right, and the right index is going towards left, and they will meet in the middle. So that is how you basically reverse a string in C. So that is SI, and we say SI is now override. We already have saved SI by SJ, and then we say SJ equal to temp. Is that all we need to do here? SJ was used and SJ was overwritten here. I think that's all there needs to be done. So that is reverse, and I think if you say run now, it will complain about as undeclared. What is as undeclared? Let's see. Okay, I think he's complaining about where line 44 he said S was undeclared. So what we could do then in that case is have something like, and then you don't have to keep redeclaring it here. Right? And then S equal to malloc. There you go. So at least we'll not see this error next time. Count digits is complaining that count digits you haven't defined. So how are we going to implement? How are we going to implement count digits? So that's in count digits. So what do we think we should do here to count the number of digits in a number? I would say I would just return something like this. Does that work? Basically, we are saying that suppose if you have something like 132, it would give you something like 2 point something plus add 3 and floor, so that gives you 3, and that's all we have. So that should take care of that problem right there. So let's see it now. There you go. So that is working absolutely like a charm. Let's see, let's try to submit and see if that works. Awesome, that's great. So there you have, folks, the implementation of Fizz Buzz problem 414. Oh, actually, I think it was 412, I guess. Let's see. Yeah, 412, Leetcode 412, Fizz Buzz in C with all its intricacies of malloc and things like that. So what are the takeaway from this? I would say if you have been doing a lot of C programming lately, these tricks like reverse and all should be very common like stuff, and shouldn't even have to worry too much about that. One thing that I can see is that probably real lock is not required, because if you know for n there will be n number of entries in the return array of strings, why don't we just do a malloc on res with the size like here n, like in the very beginning, maybe something like somewhere over here, something like res equal to malloc, and then we say size of char star times n. I think this should have been enough, and then we can simply get rid of all these real locks and simply just keep track of a n strings thing. Every time we do a str, like we build one of the s's, these strings, we just keep incrementing n strings, and then res n, the n strings minus 1 is as it is. Only thing is that we do not have to do this real lock all the time. So basically with this approach, what is happening is that if you have a n of 50, 50 times you would be doing a real lock, because you see we start with the res of null. Whereas with this approach, we don't have to do this 50 of reallocations. We can simply do once, and so that's one thing you could probably do in your own program, and that's why I'm not doing this here. But I guess this is a very good exercise to basically refactor this code. I would see you folks in the next video. Hopefully, we'll do an interesting problem. Do not forget to subscribe to the channel. We will have very interesting software coding problems for the interviews. I wish you all the best in your interview preparation, and I will see you in the next video. Take care. Goodbye.